just going to get ready to go, and I'll hand over to Richard.
Well, good evening. Thank you, Mike, for arranging all of this. This Zooming is beginning to become a bit of a habit, isn't it?
Yeah.
Welcome, everybody, to the Western Branch. And welcome back, Andrew Landers, who, of course, was previously Secretary of the Western Branch back in the day when he was in Cirencester and I could say messing about with sprayers, as well as trying to keep Cirencester with some vestige of agricultural engineering input. I listened to Andrew's talk travelling from Kent to Devon, being a passenger in the car, I hasten to add. So the reception, particularly on bits of the A303, wasn't very good. But the majority of what I heard was absolutely brilliant. And as I've said with a number of Andrew's things, his input into research involves a lot of practical, sensibly priced research rather than such ethereal stuff that nobody can ever cope with it. So I'm delighted to welcome Andrew back to the Western Branch, and be delighted to listen to this presentation of his when he was across the water in the States, and at least holding up the British end of the world for us. Over to you, Andrew.
Okay, thank you, Richard. So I need to go down here and share my screen. Okay. Can you all see the screen? Has that come up? Let me do that. Okay. Can everybody see that?
Yes, looks good.
Yep. Perfect. And hear me? So that's good.
Yeah.
Perfect. Okay. Right. Good evening, gentlemen. As you've just heard, my name's Andrew Landers, and I've had a most interesting career and in agricultural engineering. So as Richard alluded to, for 20 years, I was at the Royal Agricultural College at Cirencester, where my friend, I'd put friend first and mentor second, Harry Catling, who was for many, many years the guiding light in the Western Branch. And this afternoon, for want of something to do, I started making a list of some of the past members that I knew. And then I suddenly realized, well, of course, that's wrong to reel out a whole load of names, because you're bound to leave somebody out. And just as I was pouring my beer of Ludlow Gold, I suddenly realized the great man who I'd left out was dear Theo Sherwin, who, and that would be extremely remiss of me not to mention Theo. And so I won't mention any other names for fear of leaving people out, except one or two who were involved in this subject area, which we'll see in a moment. So the title is Precision Spraying within Precision Fruit Growing. You appreciate that precision farming, precision agriculture, is all the rage in various aspects of agriculture, but is still in its infancy as far as fruit growing is concerned. And there are many reasons for this, and we'll see some of those as we progress. There are two co-authors. These are my two main researchers of the last 10 years, Tomas Palasia and Geordie Lawrence. Both these people were postdocs in my laboratory, and are both from Lleida in Catalonia. So they're currently locked down, and they did tremendous work. As you know, if you surround yourself with good people, you can accomplish much. And in this case, these two young people were fantastic. And it's a credit to the Spanish education system. But as a part of my introduction, when I was looking up my institution activities. In the old days, so I went to Cirencester to teach in 1975. And so, like most organizations, it's not long after you join the local branch, you get given a job. And so you can see there clearly that I rose through the ranks, as they say, and lo and behold, I reached the dizzy height of chairman of the Western branch, and then went to council once a blue moon, whenever they were held over at Silto. And then I rose through the ranks of the council. And then I decided I would leave. Well, I left Cirencester, went to Harper Adams. Then Richard will remember, I joined the bank for 6 months, and then I joined Richard. And I can't quite remember how many months I was with Richard, but it's probably getting on towards a year. And so Richard helped bail me out. And then I took on this position over at Cornell. And some people would say it was midlife crisis. I would say it was a need for money, which is why I went. But to introduce the subject, so I was based at Cornell University, which is in upstate New York. There are two parts to New York, the Democrats who live down in the city at Manhattan, which you can clearly see, a place that we wouldn't visit very often, and then the Republicans who all live up in upstate New York, except for the town or the city of Ithaca. And Ithaca, New York is has a bumper sticker, famous bumper sticker, and the bumper sticker says 1 square mile surrounded by reality. And Ithaca is an exceptionally liberal town and goes along the road of Berkeley in California and Northampton in Massachusetts. So it leads the liberal thrust. That's where the university is. That's where I taught the students. I had 1 course per year to teach. And then the rest of my time was spent on research and extension. So there are a number of sprayers that are involved in this subject area. And here are the 2 extremes. The first is the traditional air blast sprayer. So those of you who are not familiar with fruit spraying, but are familiar with agriculture and or gardening, will know that all plants suffer from pests and disease. In particular, in fruits, we suffer from powdery mildew and a lot of insect activity, particularly in apples. And so my role at Cornell was to look at engineering designs to help the growers, we call them growers rather than farmers, to help the growers improve their spraying practice. And these 2 extremes, the one on the left is traditional air blast, developed in the 60s and comprises of a stonking great fan at the back, driven by the tractor PTO, or if you're a real American, you would have one with a big engine on it, a 250 horsepower Caterpillar engine, which would then turn that fan at some speed. And with the high volume that's required for example, citrus trees, for oranges and lemons in particular, you might need such a beast. But when you then discover that some grape grower has been persuaded to buy a machine that's pumping out 150,000 cubic meters of air per hour, and you actually only need 5 or 10,000 for grapevines, you can see it's a little oversized to say the least. And so my role was to try and introduce them to some better thoughts within this subject area. And ultimately, we moved closer and closer to the traditional tunnel sprayer, which you see on the right, which is very similar to a car wash, where you have a vertical boom each side of the canopy. You see the row of vines, a vertical boom, and the spray sprays horizontally into the canopy with very, very little drift and a lot of recycling or recirculating of spray. And we saw in our trials maybe 80 to 85% saving in pesticide use in early season. So you can clearly see that we have the 2 extremes. The one on the left, the big fan surrounded by nozzles, which blows the spray into the trees or the vines, and the one on the right, which contains the spray and is the much preferred method. So my role at Cornell was to run this international spray unit. And I was there, as mentioned, for 20 years and looking at improving pesticide application with engineering methods. And we had three main thrusts. One was to test many novel sprayers, as you will appreciate. As in other forms of agricultural engineering, there are many new machines come out every few years. Some of them are rehash of old machines that failed or fell by the wayside. Others are sparkling new ideas. So we compare different machines in apples or grapes. I've worked predominantly with apple trees and grapevines, being the two major crops of New York, the major fruit crops of New York, and did a little bit on the strawberry sprayers, but predominantly the three-dimensional canopies. The second role was to develop ways of improving deposition and reducing drift. Now, a lot of the sprayers in the world are those air blast sprayers I showed you, the traditional fan, axial fan surrounded by hollow cone nozzles. So they produce a very fine mist. And that fine mist is then driven by the air blast into the canopy. And so when we're looking at how well does the machine work, we look at two major factors. One is how does it improve deposition? And tied very closely with deposition is penetration into the canopy. You'll appreciate that in all fruit crops, the canopy can become quite dense in middle to late season. And then the other major area of interest is reducing drift. How can we adjust the machine to stop spray drift? Because spray drift, as you know, is not welcome by society, and most of us would say rightly so. And so if there are ways of reducing drift, then it should be encouraged. The reason this second one is of major importance is because when growers start off, let's say you want to establish a vineyard, and so it costs a lot of money to get established, maybe 15 to 20,000 pounds per acre. You'll excuse me using acres. So 15, 20,000 pounds per acre, which is a lot of money. And so by the time you've then, besides the establishment of the vineyard, you then need to have a winery. So you need a press, you need stainless steel tanks or oak barrels. It costs a lot of money. And so they then realize you need a sprayer to spray it because you've got disease and they have no money left. So they buy these secondhand sprayers, and their question is, what's Cornell going to do to help us improve it? And so the third arm that I had was to hold extension demonstrations. So in America, extension is another word for advisory service. So just like ADAS and people like that, or nowadays Hutchinson's and a fruit company down in Kent, we hold demonstrations of these different types of sprayers. And you can see this is my team at one stage. I usually had 5 to 7 people in my lab working. Some were summer students, and then always a technician and a couple of postdocs. So over the 20 years, I've employed a lot of people. But this is the challenge. And wherever you are in the world, the challenge is the same. And so this subject was very transferable to other places. So I've traveled the world. There's this misbelief in the world that if America put a man on the moon in 1968 or 69, whatever it was, I've forgotten, then surely everything else they do must be spot on. Well, you can see from the last week's exercise in democracy how well they are up to speed on doing any damn thing. So anyway, they're spraying. We tried to develop some good systems, but the challenge is the same whether I'm in Australia or China or whatever, South America. So to reduce the drift, top left-hand photo, you can clearly see the type of drift that growers and their sprayers create in early season, the first few passes until the leaves break out and the canopy develops. The problem is, in the bottom two left and middle photos, is operator contamination. And you can clearly see, those of you who are tractor buffs, that these John Deere tractors are well plastered in spray. The left-hand one in Surround, which is a kaolin clay, an organic insecticide, which so it's relatively safe for the operator when they have to go and perform maintenance on the tractor, daily maintenance, but produces a very poor image of the farming business. So as you know, a lot of wineries in the world have tasting rooms or cellar and where the public are encouraged to come and taste the wine and then buy a case or two. If you drive by with a sprayer looking like that, you'd wonder what on earth how good is this farming business? And they pay any attention to their work. And similarly, the ones in the middle. This is showing diphane, which is a fungicide, which is not particularly nice. And so again, the tractor, I got them to park next to a similar model, John Deere, so you can see the difference. And so we want to produce quality fruit, and we want to produce, in the case of vines, then quality wine. But of course, from an agricultural engineering standpoint, I put this slide in because I think it's terribly important that you should know your target. And what is the target? Is the canopy? Is it the fruit or the cluster? What are you actually spraying on what occasion? And appreciate then, certainly in upstate New York, farmers and growers might spray 14 to 16 times in the season. So they're up and our seasons are very short. Appreciate in that northern area where we might be spraying certainly from May until harvest in September. So a very short window. So if you're spraying 14 to 16 times, that's a lot of spraying. And traditionally was done on a calendar basis every 10 days, but nowadays is done by IPM, where you look at threshold limits of the insect or the disease. So know the target. The canopies vary considerably within grapes, from 1.5 meter wide rows all the way up to 2.5, even 3 meter rows, depending on what part of the country people are in. Appreciate that the farmers buy a traditional sprayer, one size fits all. And this, of course, means it's a compromise. And so it's not particularly good at anything it does, but it's very versatile. And so you can see on the lower photos how the canopy grows as the season progresses. So our target is changing all the time. And so the growers are aware of the changing target, and so have over the years learned to change the application rate. So on the first photo in May, they might be applying somewhere in the region of 150 to 200 litres per hectare if they're modernists. If they're not, they would apply 500 litres per hectare. But they'd apply that 500 litres a hectare throughout the growing season, which our thrust was to say, along with pathologists, with scientists and entomologists, that they shouldn't be using the same liquid flow rate. They should also adjust that according to canopy development. And so you might start off with 150 litres a hectare, and by the time you finish, depending on the variety, the trellis, the season, you might be putting on 500 to 650 litres a hectare. So a lot of variation in liquid, and the growers got to understand that over the time I was there. But as you know, or hopefully have realized from that machine where you have a big fan, that liquid is not the only fluid that's being pumped. We're also pumping air. And so it was the air that created all this drift and in fact limited deposition, as I'll show you as we progress. So if we take apples as our example, you can see on the right-hand side, the traditional apple trees were big. They were huge trees, the trees you recall as a young boy scrumping apples. And so big old trees. But the modern orchardist has gone to the trees on the left. You can see these are spindle trees. They're very narrow canopy, maybe only 3/4 to 1.5 meters wide, very narrow, very well manicured, pruned, in the winter, pruned in the summer. So they are, like growing roses. They're extremely well looked after, and they're much narrower row width. Now we're down to looking at 3-meter row spacing compared to the big old trees on the right, which were anything 5, 6, 7 meters apart. Big voluminous trees. Nowadays it's nothing like it. It's like hedges. And undoubtedly the trend across the world has gone to these what we call spindle trees or tall trellis trees. Lots of rows per given area, so timeliness is of the essence, as you know, with any spray, and so more and more demand on better timing. Unfortunately for the growers, but fortunately for me, in my work at Cornell, they were using old sprayer technology, 1960s technology, excess air volume, as I'll show you later, huge volumes of air, going at the wrong direction and the wrong speed. So this gave us a good introduction to get into some research, and certainly a zero finesse, particularly when we compare it to the modern sprayers. So lots of opportunity. So this is what I mean by not very good airflow characteristics. You can clearly see, and these photos aren't staged or photoshopped. This is what we see, and this, of course, is what society sees, and they don't like it. And the farmers don't like it either. But the manufacturers were not so good in the past at giving them any variation in air output, for example. So it's the air that's creating these vast plumes of spray. So early season is the first part that is the bugbear. And so as you can clearly see with these grapevines, top right-hand photograph, you can see there's very little canopy growth. And so there's what would be a large canopy late season is very small. We're just at bud break. And so we start spraying. This would be in May in upstate New York. And so we decided we'd fit, very simply, some Banner infrared sensors. You may be familiar with these, some of you. These are things you see in shop doorways when you go in and out of a shop. They click as you go through the door. So very simple infrared, and connect those to some solenoid operated nozzle valve bodies. Off all this stuff off the shelf, and let's just see what can happen. And as you'll appreciate, when the infrared signal goes out, if it hits a target, it bounces back. The banner says there's something in the way, and it opens up the valve and gives you the squirt. And you can see clearly, bottom left photo, where we're giving it a squirt, just 1 or 2 nozzles open, just squirting against the canopy as the canes, as they're called, the canopy trails over the wires, the trellis wire. And then, of course, when it sees a post, there are many posts, every 3 vines there's a post holding up the trellis, it will switch on all the nozzles. So you can see in the bottom photos, a few nozzles on compared to all the nozzles on. And so in our research, we looked at how much can we reduce the spray. So in the variety Vigneault, which is a French hybrid vine, you can see in 2009, the first spray of our season, June, 3rd of June, 40% reduction in spray because there's very little canopy to intercept. And as we progress through the season till July, a month later, there's more canopy that's grown, and therefore there's more leaves to intercept the spray. Similarly, in 2010, you can see, again, some similar results. As the canopy develops, the leaves intercepted. On all of these slides, you'll see, and at the lunchtime conference, a webinar I gave, I've referenced the slides. So if you're excited by these sort of results, you can go and look up the paper. You'll appreciate well, if Cornell regards itself, well, it is an Ivy League university, so it's a high-end university in the States. And so it's very much a question of publish or be damned. And if you didn't publish, you'd get fired. That's the way it is. And so we published a lot, as you'll see. At the same sort of time that we were playing around with infrared sensors, we worked with a big federal grant. So the feds gave us nearly $4 million, gave us, a group of us, that's the company Southern Garden Citrus down in Florida, Carnegie Mellon, the Robotics Institute at Pittsburgh, and University of Florida, who were close to the Southern Garden Center, a big grant to look at integrated automation in the fruit industry, particularly, so the fruit industry, sorry, is referred to in America as the specialty crop farming sector. And they were looking at giving big chunks of money for research. And who are we to deny them the pleasure of giving it to us? And so we all joined forces to create an autonomous tractor and an autonomous sprayer, for want of better description. And you can clearly see in these photos that John Deere were really onto this pretty fast because they wanted to, get them at the front of the market. And so they kindly lent us these tractors. And on the top of the cab here, you can see a LiDAR unit, which was used for sensing canopy, row width, all that stuff, bristled with GPS, etc. And the right-hand photo shows our part. Our part was to develop this automatic sprayer to go on the back of this automatic tractor. And you can see the difference in tree size just at that row nearest the camera. So citrus trees are huge. They're very, very dense, incredible. You couldn't see through them at all. There's no daylight showing through. So it needs a lot of air. You see the big sprayer there, huge volume of air to get some penetration. But sadly, about 10 years ago, or more than that now, 12 years ago, the citrus industry in the States was hit by a disease called the greening disease. And this is spread by a little insect called a psyllid. And so it resulted in these orange groves, particularly in Florida to begin with. It ultimately spread to California, but where the other sector of citrus is grown. But in Florida, these growers, for example here, Southern Gardens, were replanting 15% per year. If your tree gets the greening disease, it dies. It's as simple as that. It's like fire blight in apples. It just gives up the ghost and dies. And so you have to cut the tree down, go away and burn it and get rid of it. And so there was huge pressure. Orange juice, as you know, is a major, major industry in the world. And so to lose that industry would be a disaster. So we have these small trees, which are our target. And we have these big trees that are our target. So in all cases, we need to be able to adjust not only the liquid, so the little tree might want the equivalent of a teaspoon of spray, and the big tree might want the equivalent of a bucket full of spray. And so we want to be able to do that quickly. And we will see in a moment how we did it. But because of our interest in airflow, we also wanted to be able to adjust the air rapidly. And this is within, half a second, these adjustments should be made. How did we set about doing it? Well, when we were working in the citrus industry, we used a thing called pulse width technology. We used LiDAR sensors, and we adjusted our airflow with a louver system that we developed at Cornell. But my knowledge of farmers across the world is that farmers are, should we say, cautious with their money. And the sort of results we were getting from a $4 million grant would be too expensive, the equipment side, too expensive for the growers of upstate New York and all the other states that I come across in apples and grapes. What could we do that would be simpler? So we started looking at ultrasonic sensors. These are really inexpensive, readily available off the shelf. And so as some of you will know, because they've been used in society for many, many years, sends out a signal, so it acts as a loudspeaker, and then any sound wave that is reflected by, in this case, canopy or tree trunk or vine trunk, vine canes, the reflection is picked back up. So it acts as a microphone. So a loudspeaker and a microphone in one for fairly low price. One of my researchers, Tomas Palasia, he struck on the idea of measuring the range of density. In our earlier trials, and here you see one of the sensors on the mast at the top, in our early trials, we just measured the distance to the edge of the canopy, T1, as you can see in the diagram, which was mighty fine, except that we discovered that old rows of trees or old rows of vines are not planted by modern laser planters or modern GPS planting machines. They were planted by hand. If you've got a tree that's 30 years old, you wouldn't have had any of these modern things to help you. So they're planted by hand. The second thing is that most of us, or some of us, but certainly me, but lots of other people, are unable to drive in a straight line down a row of trees. And so we were getting variation in our results. And it was only Tomas's work that looked at using the range, T2, that would take into consideration the variations in row straightness, if you like, or curvature of the row, and or tractor driver's ability. Okay, and so as the ultrasound went out, the bounces returned, and we would create a graph. Here, this shows you the sensors on the vineyard machine and on the apple orchard machine. Different positions for different height crops, and we could adjust them on the mast accordingly. We used a very simple traditional French sprayer, a Berthoud, a little air blast sprayer, behind a very old tractor, Ferguson 135, very old. And you can see our results in the first year of trials, 2014. You can see clearly the date on the x-axis. Notice that, the American way of putting in the date back to front. So we start off 21st of May and we move through to in this case, the 19th of August, looking at the apple orchard. You may or may not know that in fruiting crops, each side of the canopy produces a different amount of canopy, different amount of fruit, different ripeness, due to its orientation with the sun. And certainly we were able to track which side gave us a different signal. You see on the y-axis, WCR is the voltage that's coming off our sensor. So we're picking up this return wave, this sound wave. And the point to note, as the season progressed, the signal grew. Clearly, you can see on the X versus the Y-axis, an increase in signal. Then notice on the 30th of July in our state, we started to hit a snag. And then on the 29th of August, we hit a major snag. And that major snag was a hailstorm. And let me get that right. At the end of July, 30th of July, we hit the hailstorm. Our next reading showed a decrease in signals. And when we go to the 29th of August, a month later in the vineyard, you can clearly see the signal has changed and has increased again. And the reason for that is that the canopy was netted to stop the birds eating the damaged fruit. There was seeing a big hailstorm is really, really scary. And at Geneva, everybody's research plots were decimated by the hail. So we had no results. So the benefit was we had no results to write up in our reports, no stats to do and nothing. But it was very, very disappointed. So we carried on and we asked our colleagues, how do you measure canopy? Because we wanted to see how accurate our sensors were. And they use a system called point quadrat analysis. And here you see it. We created a simple frame following their directions. And it's so simple, you wouldn't believe that it was a recognized scientific instrument, but it is. And what you do is poke a stick, a bamboo cane, as you see in the bottom left diagram in an apple tree. You poke the stick into the canopy and you poke it right to the midway position, and you count the number of leaves or fruit that hit the stick. It is as crude as that, but it stood the test of time because it's simple and is very straightforward to understand. What we wanted to do was compare our ultrasonic sensor with the real life situation and the proven scientific method. And so once a week, our tractor went past a given number of rows in a vineyard, given number of rows in an orchard, and within an hour of the tractor going through, our summer researcher would go through and measure the number of leaves hitting or striking the bamboo cane according to the frame. So 2015, 2016, we analysed 2 vineyards and 1 apple orchard. The variety Vigneault, Cabernet Franc are the apples, and the variety Macun is an apple variety. And so weekly trials, carrying this out, 4 treatments per row, etc. And you can see again the growing canopy. So you can see how canopy density is what we're looking for, how that changes. And here are our results. You can clearly see on the right-hand graph, when we look at point quadrat analysis, PQA, the traditional number of leaves or orchards, leaves or fruit striking the bamboo stick, we just get these low numbers. And equally, when we look at what the sensor is seeing, we can plot one against the other, and you can clearly see we got fantastic results. So we knew we were on to something of great interest. When we look at Macun, again, the apple variety, you can see, again, the change in canopy, and again, the results, bottom right-hand diagram and the middle bottom diagram. You can see we're getting a fairly good representation of what's going on. Then we had to put it all together on a modern sprayer. So here's an apple sprayer with a tower, which we then developed to change. You can see the mast at the front. And so we developed it to change liquid flow and air flow. In the citrus method, when we had $4 million to play with, we chose to put on the back of this big air blast sprayer what's called pulse width technology nozzles. These were invented by Ken Giles, who's an agricultural engineer working in sprays in a teaching role and research at University of California at Davis. So the pulse width technology nozzle is very similar to a bubble jet ink printer. And there then it comprises of a small solenoid which lifts up and down, opens a valve, lets the valve go, open and close, many times, maybe 40 times a second. So it's very, very rapid, just like a bubble jet ink printer. But it's beefier and has been developed and is marketed by Capstan all across the world. You'll come across these. Being aware of our growers' needs in upstate New York, we decided that was too expensive, too sophisticated, and because growers don't just supply liquid spray, they apply foliar feeds, they apply all sorts of powders. These little things may bung up in the quantities being used in apple trees. And so we went to the Lechler Vario Select. Lechler, as you know, is a German nozzle manufacturer, make very good nozzles, and they kindly gave us these Vario Select systems, which we'll see in a moment. There it is on the right-hand photograph or diagram. You can clearly see it will allow us to use a nest or an assembly of nozzles. The photograph shows you the 4 nozzles in the holder system, but we only actually used 3 at any given time, or sorry, 3 in any of our trials. And you can see on the bar chart on the left, by using various nozzle combinations, You can see the yellow, the orange and the green with a check mark or a tick in the box. You can see the flow rates that we were obtaining in litres per minute. And so we can go from about 0.3 litres per minute all the way up to about 1.55 litres per minute by switching on and off different nozzles, by opening or closing. And so the nozzles on the Leckler are operated, in this case, by a pneumatic system. There's an airflow which would adjust the which nozzle or which combination of nozzles were open. And so you can see by just using 3 nozzles instead of a single one, we can get a combination giving us 7 different application rates. So very, very simple. And if you include the more switched off, we've actually got 8 rates from 3 nozzles, which is pretty impressive. So we're quite pleased with that. And you can see our results. Traditionally, the farmer would apply the same rate throughout the field, throughout the orchard. And so the red line shows us the conventional flow rate. Excuse me, putting gallons per minute, but that's what it is. And so it's just over 3 gallons per minute. But when we calculated what we should get with the ultrasonic system for a given canopy, and then you see how the sprayer actually worked. We put a flow meter system in to monitor the flow going to the nozzles. You can clearly see that we could have much greater savings throughout the whole system, throughout the whole season. And that shows here. We reduced our system quite considerably, and we went down from 1,120 litres per hectare down to 870 litres per hectare. You can see it's really easy, this metric system. When you're using standard or imperial units, you just add a 0 and it converts it from acres to litres per hectare. Then the airflow became of great interest. So we'd been playing around with airflow probably after about a couple of years after I arrived at Cornell, because no one else had done it, and it was a good opportunity to develop some engineering methods. And so we used these Gill sonic anemometers. Gill's a very famous anemometer manufacturer. These were 3-dimensional sonic anemometers. And we mounted them on this mast, you see, by the side of this sprayer. We've done a lot of work with the variety AC Mac at Lamont Fruit Farms, probably for 15 years. So we had a lot of data about canopy development. And in this case, the mast is the other side of the canopy. So the sprayer runs down between 2 rows of apple trees, and the ultrasound sensors are mounted the other side of the canopy. So we can detect the amount of air coming through the canopy at different growth stages, and we can detect the effect of forward speed on air penetration, because a lot of the deposition is related to airflow, particularly then air speed and air volume. This is the traditional system where there's no air adjustment. This type of sprayer, and any other sprayer for that matter, with these narrow trellises, will blast the spray right through. And this is unacceptable. All that ground contamination, so that's not very good, and it's not good at all. And also the growers, they die when they see all this spray not hitting the target. You'll appreciate they're probably spending upwards of £1,000 per acre, so £2,500 per hectare on sprays in upstate New York and in most other parts of the US. Pesticides are a high part of their input costs. If we apply some engineering method, as I'll show you, this is what we can attain. We can reduce that flow through the canopy and keep the spray where it should be going. And I'll show you, I have a video showing you that later. This type of work excited others in horticulture because we can see from this graph the effect of different varieties. And here we have a number of different varieties, six varieties, and they all have different densities. And this then will dictate how much air, how much liquid is needed by this, from the sprayer. And people were unaware of this. The PQA was their only other method of measuring density at that time. And this then was labor intensive. And so it wasn't done very often. Whereas with this, it can be done fairly quickly. Here then is what we developed. You'll see here is a modern sprayer. This then is not the air blast. This is the Australian sprayer using what are called SARDI fans. SARDI is the South Australia Research and Development Institute. This group based at Loxton in South Australia. They also have a big labs down at the Waite Institute in Adelaide. So I've been to Australia a lot because there's a lot of fruit grown, a lot of good wine comes out of Australia, all that beautiful sunshine. And so we saw a lot of these sprayers in use in Australia. Probably 2/3 of the Australian sprayer design is like this. So they started coming into the US and they've started coming here to UK, and they have a number of advantages. One is that the fan is relatively small compared to an air blast. So with a narrow tree canopy, as you see, we can have a small volume of air blowing through a very narrow canopy. So this is a good thing. And because it's, in this case, hydraulically driven, we can adjust the hydraulic oil flow. There's one other variation, invented by the same group at SARDI, it uses an electric motor, which would be much easier for automation. But the majority have gone with hydraulic flow. Farmers are still a little nervous about electricity and water. And so the SARDI green tech is not as popular as the SARDI version that uses this system, the croplands, SARDI croplands. And so I'll start the video. On this sprayer, we have our sensor at the front using ultrasonics to measure the crop canopy, GPS to measure our forward speed, and we can then adjust the airflow. So this is showing us just airflow adjustment in real time. So I'd shut off my volume and then you'll see it. So it starts off full bore, it'll start blowing spray through the canopy, as you saw in a previous photograph. The sensor starts slowing down the hydraulic motors, therefore the volume of air is reduced. And so we can keep that spray plume just hovering in the canopy. If there's a gap, it'll pump through, of course, but it just keeps that spray in the canopy. And this, for a number of years now, has allowed this particular grower, who is very, very modern, he's an Englishman, actually, Rod Farrow, who's based in upstate New York. And Rod and I had exceptional working relationship and good personal friendship. And we did no end of trials there. And so he now sprays his orchards from one side only. So instead of having to come back down the center of the row here, he can spray from one side instead of doing sprays from both sides, because the spray has gone where we want it to go. And so this in effect doubles his output or halves his tractor sprayer requirement, whatever way you wish to look at it. So this has been most successful. Then the other thing, which is really interesting, it started off in the west coast of America with salad crops. And that has been the disaster with leafy greens, where we have no monitoring of what the sprayer is doing. And so this chart shows you the green stripes of the rows of vines or apple trees. And then if the sprayer is working at 100% application rate, you can clearly see the red stripe on each side of the canopy. So this is schematic showing us our concept. Then the second, between row 2 and row 3, you see a blue line. The blue line shows 0 application. This is because what happens occasionally, the operator forgot to switch one side of the sprayer on. You appreciate the two sides of the sprayer. There's two handles to switch it on if it's an old-fashioned sprayer, which many of them are. Then between row 3 and 4, the tractor driver forgot to go down that row. You will appreciate that spraying apple trees or spraying grapevines on the grand scale, remember some of these growers have 1,000 hectares of trees or 1,000 hectares of vines if you're in Central Valley of California. And so going up and down these rows at 3 miles an hour, to say it's like watching paint dry is an understatement. This is a bore beyond belief. And so sometimes they miss. And when they and the drivers tell me this, and when they miss, then they think, well, I've missed a row, I'll go back down that row. And that's why we get the big horror, which is double application. The yellow row between 4 and 5, row 4 and 5 from the left, double application. And this is what will give us the bad press, because as you know, pesticide residues are not wanted, particularly in the wine and apple industry, and even in table grapes. Because if we're eating table grapes or eating apples, raw apples, then we have no processing. So the fruit is as is with pesticide residue. And so, and then the last the last row there shows you a block nozzle, intermittent squirting. We're picking it up. And that's how we did it. A GPS receiver, giving us our location. Here's our sprayer. Inside the sprayer was a Raven flow meter. Raven flow meter is quite popular across the world. And so we could measure flow, and we knew our location. We had a flow meter each side of the sprayer, so we could see left and right-hand side. The Garmin GPS system we had wasn't very good at all. So we went to RFI. It's gone. It's gone. Oh, good Lord, old age. And you can see we used satellite system that's very, very expensive. We got our flow rate. You can see the satellite receivers on the top of that tractor, giving us our location. We knew our left and right-hand side, and on the bottom left, we could overlay our flow records with Google Earth, and we could see what was sprayed, what wasn't. So really, really good, but very, very expensive. Our GPS, RTK, that was the name of it, sorry, I apologize. RTK GPS, we're looking at £14,000 10 years ago. So very expensive. So one of my other postdocs, Chung Yuan Zai, who came from China, he and I struck on the idea of using RFID cards. On the end post, bottom right photograph, you see an RFID card, which will give us the location of the tractor. So a simpler system allowing us to record using the two sensors on the front of the tractor. You see the two big white sensors, record our location front at each end of the row. That was that. That's just reference to that. And that's again the same system, development of RFID. Okay. With the GPS system, RTK, because it was so expensive, the grower that we were doing our field trials with thought, well, we best try and make better use of it. And so we put auto steering on the tractor. And as you may or may not know, in the Midwest states of the US, in field crops, auto steer is the most widely adopted of any of the precision farming systems, auto steer. And so in the case of our orchard, you can clearly see if this is a number of passes through an orchard in over a 30-year life of a apple orchard. And you can see undoubtedly spraying is the greatest, but mowing is the second. And so why not try and combine the two? And so now in Europe, there are a number of manufacturers of mid-mounted and front-mounted mowers, which will allow us to combine the two tasks. Without GPS steering, it's quite a challenge for the operator. But with GPS, it's a much easier task because he doesn't have to steer. I must say, when we then took the GPS and took it with the auto steer and put it on a grapevine sprayer, which was an older tractor, still had power steering, but the power steering was a wee bit sloppy, shall we say. Say the least, it was a wee bit sloppy. And I have video, I have no time to show it tonight, but it's quite scary when you see the auto steer trying to adjust the steering wheel with a sloppy linkage system. It's really, really, as you're moving closer and closer towards the vine canopy, just before harvest, and the grower is thinking he's going to hit the vines and wipe out, about 30 yards or 30 meters of row. It wouldn't be very popular. So we took it off fairly quickly. Anyway, and then getting towards the end, airflow measurement. Because air is so important, what can we do to measure it? So we developed a simple system using strain gauges. You all know strain gauges. And so showing us the deflection of this very simple monitoring device. And so we worked on that for a couple of years. And that's where, as far as it's gone. You'll appreciate that some things languish in academic journals and other things and never see the light of day, whereas other things we get taken up, which the next thing we'll show you. That's the monitor, air monitor, the electro leaf as we call it, placed in the canopy, and works very well, but we couldn't get any commercial interest in it. The second big area that's of interest under precision work is, where does the spray go? This is a question growers always want to find out. And so top left-hand photo, quite often in the summer in my advisory extension work, we would do twilight meetings, as we call them, where you'd go along, 9 o'clock at night, spray with a fluorescent tracer. And when it was really dark, using ultraviolet, you could see the spray on the leaves. And this is a fluorescent tracer showing it on an apple leaf running to the point of drip. The alternative is use water sensitive cards, which are placed throughout the tree, as I would say, festooned like a Christmas tree. Unfortunately, the word festooned has never got to America, so they no idea what I talk about. But you can imagine, like the fairy lights on a Christmas tree, covering it with all these yellow cards. We then take the cards back, try and find them all, take them back to the lab and analyze the droplet coverage that's on the cards. And this is by far probably the simplest and the most popular way over the decades of measuring spray penetration and spray drift. But we also use a tracer. Instead of the fluorescent dye, we can use a food additive, a tartrazine, and we can see how well that's done. And so there are various ways, different researchers have different methods. Why not develop an electronic system? And that's what we did in the last few years at Cornell with Tomas Paleja. We developed an electronic system, and that's it. In its early stages, it's not how it ended up. And we have a company who's taking it to the marketplace. And this is quite revolutionary. It looks, to all intents and purposes, like a water sensor, leaf wetness sensor, they're called in agriculture. But the leaf wetness sensor is either wet or it's dry. It doesn't tell you how wet it's become. And so we envisage, making my pension out of this idea where we could, again, festoon the trees, leave them in the orchard or the vineyard all season, and then you could adjust your sprayer automatically, application flow rate of liquid. So liquid flow rate automatically with this, air flow rate with our electro leaf sensor. So we did that. And we had, again, here's our apple mimic on the right, a dodecahedron mounted next to, in this case, a bunch of grapes, but it could equally be next to, mounted in fruit trees to measure the deposition that's going in. And so my epilogue, this is the lunchtime talk the other day, Sensors can provide good estimate of density. Undoubtedly, we're pleased with our work on that. Particularly ultrasonics provide us with a much simpler system than LiDAR. Others use LiDAR, and the best of luck to them. But in the real world, we need a simpler system than a LiDAR. I'll probably get shot for saying this, question time, but this is how it is. We can then use that density information to adjust the sprayer in real time. Adjust the two fluids, remember, the liquid and the air. And then we can use electronic monitoring to look at how much spray has been applied, because this is very important for traceability. And it won't be long for one day people get pesticide residue in their apple, the baby food that's used. Don't know what they're called in this country, but they, this mushed up apple they give little babies. If there's any pesticide in that, that would be horrendous. So we need to be on our best behavior. Okay, so that was that. But that's really only one half of my job. And the other half, which is not as many slides, you'd be pleased to know, but it's only, I put 10 slides in, which I think sums up, shall we say, the more exciting part of my job. And it's been exciting because, A, I've traveled the world showing growers this, and have met a lot of interesting people. You'll appreciate the important thing, the good fortune I've had in going to the US is that my area of research was with vines. So at the end of the day, well, there are two things. There's two sayings. One, that grapes are only grown where civilized people live. This is very true. And the second saying is that it takes a lot of beer to make good wine. And if ever you meet an enologist or a vintner, you ask him that question, and they drink gallons of beer, and then they hit the wine. And so here we'll see a simple machine showing precision fruit spraying, but at a level of advisory service or extension that farmers can adapt today. And that's the important thing. So the blue sky research is all well and good to keep me employed at Cornell, but this is the other bit that is exciting, because civilized people live all around the world, as you will know. So this is a vertical patinator developed by my good friend Paolo Balsari at the University of Turin, who does in Italy what I did in the States. It's a vertical mast with stainless steel plates that pass through the spray plume and capture a percentage of the droplets. So you'll see it. It's driven by an electric motor working on this aluminium ladder at the bottom. Note my pronunciation of aluminium hasn't changed. And so it goes through the spray cloud, capturing the droplets. The droplets run down through tubes, small plastic tubes, to collecting vessels at the bottom. And as we close in on it, you'll see it passes through the spray plume maybe 4 to 6 times. There are the plates, there are the tubes run down then to the bottom, to the collecting vessels. You can just see them. We then take that rack of collecting vessels off and place them at eye level. We usually put in a food dye so that we can see the levels clearly, as you'll see. And so here's a blue food dye, and we can clearly see that because of the direction of the fan, we have non-symmetrical airflow, because the fan is going usually counterclockwise or anti-clockwise. And so on the one side, it goes up, on the right-hand side, so the top of the tree is getting plastered in spray, and on the left-hand side, it's forcing it down to the middle, to the lower part of the tree. And when we plot it, you can clearly see we can do that. I had a technician who would take this around the state, well, and neighboring states, and he would bet the grower that his sprayer was wasting 20%, 30% above the tree. And the grower said, no, it works perfectly well. I've eyeballed it. It was their expression. And he would show them this, and he made a lot of money. He would have a bet, 10, 20 bucks, 20 bucks that it was overspraying, which it always was overspraying, of course. And we developed a system of using what's called nozzle orientation. And you'll see that later. But we would change the nozzle angle, the body of the angle, body of the nozzle, and be able to adjust its orientation. Farmers couldn't afford the Italians' patinator, so we developed simple patinators. Here's one made of window screen. In America, they use fly screen material over the windows, stop the bugs getting in. And we put these online. The growers could make them. And so that was also very successful. Some growers even poo-pooed the idea of spending $300 on building a patinator. And so we would show them how to attach water-sensitive cards, which we discussed earlier, to vertical poles, conduit, metal conduit pole, or wooden battens, just to simply measure what's going on. Then the other area we worked on, because we worked on a lot of airflow stuff, we looked at airspeed. This was a subject that no one had looked at in fruits to any detail, what's going on. And so we looked at the effect of airspeed around an apple or a bunch of grapes in a wind tunnel. So we had a small wind tunnel, and in Ithaca, where Cornell's based, one of my colleagues in the 60s had developed a fascinating device which creates helium soap bubbles. It's like, you imagine a hypodermic syringe needle, but comprising of one needle inside an outer needle. So an inner needle and an outer needle. And what we could do was to pass air bubbles of about 200 microns in diameter. So these bubbles were soap bubbles. So 200 micron diameter soap bubbles. So it would mimic a spray droplet, because our air blast sprayers were creating a VMD of 200, 230 micron diameter droplets. We could copy that and we could watch what was going on. The beauty of soap bubbles that are full of helium gas is that they have neutral buoyancy. They would go where you put it. And so we could take a soap bubble, a stream, about 300 bubbles a minute would come out of the device. And if you put them in the middle of the room at eye level, they would stay there, unless there was some air turbulence, and then they would just waft around in the air current. But they've been used for computer designing. Nowadays computers design cars and smoke. But in those days, soap bubbles would be designed. You could look at the windscreen shape, etc., etc. And no one had applied it to agriculture. And so we thought, this is fantastic. So off we go. I have a little video which I show the growers, because you remember the Royal Agricultural Society of England used to have a motto, probably still have the same motto: science into practice. This is the target for all extension people. Apply the science. How can the growers see the science in real time? So here it is. Here's an apple, we're on the size of an apple. There it is, 4 centimeter apple in a wind tunnel. The droplets are coming from the left. Our machine is feeding them in. There's no airflow. But watch what happens once we start the airflow. The droplets will come from the left-hand side. Well, this is looking at the apple from the underside, as you can obviously see. The droplets come from the left. The boundary layer effect is set up because of the round effect of the apple. And so the droplets go over the top and under the bottom of the apple as we're looking at it. So we get a point of divergence. As we increase the speed, the point of divergence moves to the left and the point of convergence moves further to the right. That apple is only receiving spray droplets in a few places. It's getting hardly anything on the back, on the rear of the apple, okay? And you all know the density of an apple tree. You've all seen apples growing. It's a real challenge to get that. But now we can show the growers exactly what's going on. Isn't that great? So we had a lot of success showing them that. And in upstate New York, where we used to get a lot of snow, they saw this. Ludwig Prandtl, as you may know, is a German physicist. He was the father of fluid dynamics. Anyone who studied that at college will know fluid dynamics. This was our man. And interestingly, in 1910, he published a paper on airflow around a cylindrical object. And this, what is an apple if it's not a cylindrical object? What is a bunch of grapes when you view it from the underside? A cylindrical object. And so this is the bottom right, shows us the sort of thing that we see in practice. This is a narrow spindle tree. The apples on the end of a branch, so the apples nearest the sprayer, are rotten. They're diseased. Whereas the apples further into the canopy, as you can clearly see, are quite good, a really good quality. Why would the apple nearest the sprayer have disease when you've applied a fungicide in this case? It's because of the work that Prandtl did, showing us that airflow diverges, and the faster the air goes, the less you get of convergence at the back of the fruit. That's why the apple got the disease. And so how do you relate this to a grower? Well, all growers are fascinated by cars, I find. The faster the car, like many men, the growers are predominantly men. There are some women growers, but my audience is predominantly men. I talk to them about the Audi R8 Spider. This is the car. I tell them, sell your vineyard, sell your orchard, buy an Audi R8 Spider, put the roof down and drive. So here we are going along Route 1 in California, and you can clearly see you're driving along, it starts to rain. I say to them, what are you going to do? Go faster or slower? There's always someone who says they'll go slower, and they'll stop and put up the hood at the convertible roof. I tell them, no, well, you don't stop if you've got an R8, you just floor it. And as you know, the air goes up over the bonnet, over the windscreen, and converges way up the road to you following behind in your farm truck or whatever. And so to drive home the message, how do you adjust the spray so it deposits? You shut down the airflow. You drive your Audi R8 slowly, you get covered in water, in rain, inside the cab. So things like that, trying to get the message out. And then towards the end now, why is this stuff hitting the sleepers or the buffers in a railway analogy? Because in many cases, horticultural people, growers of fruit crops, then have a fear of technology. That's the first thing. But the question has to be, where's the labor? Who drives the tractors and the sprayers? You'll appreciate that if you grow more than an acre of apple trees or half a hectare of apple trees, half a hectare of grapevines, you have a lot of work to do with pruning, spraying, etc. So you need to employ somebody. Well, if you're going to employ one person, that means you're not doing as much. So you move into a management or a supervisory position. Well, not then employ two people. So these big orchards have hundreds of workers, hundreds. I was at an orchard in Brazil 2 summers ago. They employed over 3,000 people. It was an amazing logistics event to get these people fed lunch. I can tell you, 3,000 people. And so there's a lot of labor involved, but it's the availability of good labor. And so others have done surveys, the standard of education, the cost of labor, how much income you get. Remember, most farmers don't have a lot of income, and this fear of technology. So I show them the photo, bottom right, which is in the engine compartment of a Ford F-350 pickup truck, which bristles in high tech. But they have to pay $90 an hour for service, for repair bills. Most farmers like tinkering, and so in horticultural crops they tend to steer clear of that. One other quick thing to show you. So I do a lot of work in California, I still do a lot of work in California when I'm not locked down. And so this Central Coast vineyard area, Paso Robles, San Luis Obispo, in that region of California. The use of a drone to measure, or not to measure, to show growers spray drift. This was our early days, but with good photography, you can get closer in without getting the lens covered in spray, and you can show growers that in this case, here's an electrostatic sprayer, just doesn't cut the mustard. And so it gives us a totally different perspective on spraying. And just to finish, not all our work was with spraying, but as an engineer, people come up and say, what else? We don't use sprays, what can we do? Here's a fiber wrap. We played around with this for a couple of seasons. This is just with a glue gun. It worked really, really well. You imagine covering your plants in, say, this country. You had some cabbages, young cabbage. You could take your glue gun out, cover it in fiber, and it would go stop the butterflies, get the white butterfly, cabbage white, getting to your brassicas. Things like that. We played around with all sorts of things, knitting wool fibers, all sorts of fibers. So anyone anymore, I'll give you that as something to look forward to. And finally, as I mentioned at the last institution webinar I gave, as this is a pro bono presentation, if you let me indulge in 2 seconds on my books. I sell these books online to growers. We've had, I have to say, a lot of success with the books. And so it's based on our research and extension work, showing growers what we can do with their sprayers so they work a lot better. And finally, I must acknowledge the companies that have funded my work, state-funded research companies, a couple of manufacturers that I would mention, a lot of growers, oodles of growers across the US, and then my colleagues, particularly in my own lab, all my postdocs, and all the army of summer workers that I've had. Been really, really good. Okay, so there we are. That's it. I apologize. I noticed I ran over a wee bit. Now let me get back to you. How do I do that? Stop the share. There we are. Okay, good.
Andrew, thank you very much for a cook's tour of the spraying technology for the horticultural and fruit sector. Certainly, probably like some of the other listeners and viewers this evening, this is an area that I have very little knowledge of. I'm sure, like many others, I've sat on a balcony on holiday with a glass of wine, watching the evening activities of the narrow track tractor going up the rows, and said, "Oh, that looks interesting." Yeah, certainly a lot of information there. So we've got the opportunity for some questions. We've got 17 participants. Is there anybody specifically there that wants to raise questions? If so, do you want to put them in there? Just to get things going, maybe with the questions then, Andrew, where are we on the journey towards the automated self-propelled sprayer?
Yes, what a good question. Long way yet. As they used to say in America, don't give up the day job. And so the area that's of greater interest than taking a big sprayer and traditional sprayer is to start at the other end, just take 2 or 3 nozzles and go and do spot spraying on the back of a small robot. So if these small robots deliver what they promise that they'll deliver, and I use the word promise, then I can see that as being a good way forwards, where it can work a 24-hour cycle and go and spot spray where disease is occurring. And we've got a lot of work being done in various parts of the world using what are called electronic noses, which will detect changes in the canopy, in the atmosphere in the canopy, as, for example, powdery mildew starts to develop. And so if you can then go and fire a squirt of spray specifically at that area, it will help. But still a long way off, because the growers I meet, and I meet thousands of them, they're not into that. The margins aren't there to pay for high tech. Couple that with the fear of technology, and we have a long way to go.
Oh, well, thanks very much. We've got a question from Bill Basford.
Yeah, thanks very much, Andrew. Our paths have crossed over many years, but not very much recently. One thing that really hit me is your reference, and you've just alluded to it again now, is that, you know, Americans got to the moon, but they don't seem to be able to get detail on simple spraying improvements. But I'm not going to shoot a line about the UK, because I've been to too many orchards and latterly inside protective cropping, where the approach to crop protection is pitiful, I would have to say, absolutely pitiful, almost using car washing guns on very valuable crops. And it just worries me a bit that I believe in your early days you did a bit of machinery cost benefit, that people can't see the benefit of going on fairly simple improvements, using deposition checks like the water sensitive paper, which, you know, I've used many times.
Yes.
Trying to get that battle. How is it that we can get through the simplicity of the message when people are going to be saving 40% of pesticide? Don't they add that up and say, well, we can do some investment?
Yes. I quite agree with you, Bill. It is shocking when you go to protected cropping, to greenhouses. That's the same the world over, the big spray guns. It's really bad. And environmentally, of course, a lot of work done in Scandinavian countries on the amount of residue coming out into the drains from these. If you imagine Almeria in Spain, with all of, I think it's 30,000 hectares of covered crops there now, the pollution that goes on into the ground must be horrendous, absolutely horrendous. So how do we get this message out? I think the old adage in extension and in advisory work had always been drip, drip, drip. So after about 3-4 years, they start to listen. Well, they might. I think the younger ones listen. And it's certainly in grapevines. It was fascinating. There are two distinct areas of grape production in the world. One is the third generation in the US, certainly third generation in Europe, even longer, multi-generational. And so now they learn from their father and their grandfather. They learn at their parents' knee. And so they're really carrying out 1950s attitude towards growing vines. The ones that were the most exciting were those that had been successful in, let's say, high-tech companies, Silicon Valley type things, that would sit, as Mike alluded to, on a balcony and say, we could grow our own wine. And these people, because they're successful businessmen in one business, apply that same mindset to agriculture. And they, I use the expression, they're like sponges. They will pump you, absorb everything you say, and then they will instigate it. And it's really refreshing when, and so it ends up like this, like the orchardist, Rod Farrer, the one I mentioned, who's British, who's at Lamont Fruit Farms. People like that travel the world, they see what's going on, but the multi-generation ones never leave the county. And this is sad, but this is human nature. And so I think we spend our days working with the top 1% of growers or farmers in the nation, or do we try and get the bottom 30% to lift? It was always a challenge for us in extension to not to concentrate on the 1% too much, but that's where the rewards were, professional reward. Yeah.
Thank you.
Thanks very much, Bill. I noticed that Richard, your microphone was open there. Have you got any questions for Andrew?
Well, one of the, or perhaps I need to recount, one of the machines that we designed and built that almost worked but not quite was a machine for painting fences. And if only I'd had access to what Andrew's just been doing with these fruit vines, we'd have probably made it. The two things we needed were Andrew's input and what's now available is water-based paint, because cleaning up the horrible paint that we were spraying was a disgusting operation. But I'd say as I said in the introduction, really, the impressive thing to me is this using common sense and economically priced solutions to problems which can be solved by a huge amount of money, but actually don't work because nobody's going to use them. And I thank Andrew for introducing that, or for following that line.
Yes, I have to say, I learned that from my good friend Harry Catling, who some of you will know, Bill and Richard and others will know, who was a Yorkshireman. You know, that old saying, you can always tell a Yorkshireman, but you can't tell him much. I wouldn't agree with that saying, but I often use it. But Harry was a great one for saying, yeah, that won't fly. That's not going to fly because it's not applied enough. And I go to, like everyone, you know, you go to some conference and you hear some really great stuff. And then my mind goes back to what the people I refer to as my growers back at home sort of thing. And I just think, yeah, it's great research, but it'll sit in a journal forevermore. It's not to come out. So it's, yeah, good practical application. Thank you, Richard, for your work. Yeah, it's very important.
And I noticed, Rupert, you had your microphone off there. Have you got a question for Andrew? Oh, maybe not so much there. Where do we sit with regards to the overall issue of things like you know, the carbon footprint and reducing food wastage, and you know, the influence on chemical addition?
Well, the pressure's always on about the chemical addition. They don't like it. No, it's interesting. When you have time, all of you, yeah, if you're, well, say you're having a pre-prandial gin and tonic, and you start thinking about food waste, and you look at what the big ag chem, you know, big pesticide manufacturers are saying, we need to increase production by the year 2050 for all these millions and millions of people that will be here. And then you look at the results by people like FAO and the European Union, who've looked at food waste. You know, the amount of wasted potatoes in this country is phenomenal, absolutely phenomenal. You go to tropical countries where you then get a whole raft of other things, it's even worse. And so I think pesticide application in post-harvest technology is where the future has to be. If we can reduce food waste in storage, then we'll be into a good bet without squirting more stuff on the growing crops, I have to say. Probably get shot for saying that, but it's how I feel in my dotage that, you know, we have to take more account of the environment and food waste.
Well, certainly with regards to the you know, the household shopping and the ability to look at the food label and get a, you know, an indication of you know, what's happened from field to fork is obviously a factor. I'm just looking through the questions there. I don't think we've got any more questions specifically at the moment. If there is, please raise them. I think maybe.
I'll give you another one, Mike, if you like.
Yes, please do.
Comes back to sensors, really, Andrew.
Mhm.
You've used a number of devices for measuring wind speed and deposition. I remember, it shows a bit of age, we played around with barcodes on pesticide containers and automatic reading, and the sky was the limit of, you knew what was there, you knew what had been used, you knew when you'd got to a threshold, but it got dirty with spray deposition. Were there big problems in all the equipment that you were using in fruit work?
Well, interestingly, for the ultrasonic sensor in fruit trees had been around about, well, certainly 15 years before I arrived in the States. One of the companies had fitted them, and they got a very bad rap. And then in discussion, they came up with the idea, if they can put the sensor further into a tube, so you imagine the ultrasonic sensor into a tube, not too far down the tube, but it would reduce the amount of deposition that came from drift flying around the sprayer. But they still needed, say, every lunchtime, maybe twice, 3 times a day, somebody to go over the sensor head with an old rag and clean it. And people are, well, I don't wish to be derogatory, but some people are quite lazy. Even that simple task, which would reduce their spray use considerably, was too much of a challenge. It's unbelievable. And I've come to the conclusion that people, farmers have so much on their plate, with variety, fertilizer, spray, marketing, all the myriad of things that they have to do, that they're unable to share, Bill, you and I, our enthusiasm for farm machinery. They'd love to, because they like, all farmers love machines, but they don't have enough time. So they go for the simplest fix. And if that means, well, this technology might break down, well, you need to have the technology so that you can override it and then use it manually, as they currently do. And again, lots of manufacturers forget that. They don't have an override system. So the things, I've known a grower very well. He bought a brand new tractor. He loved it. And he showed this New Holland tractor. It was fantastic. And saw him a couple of weeks later. I said, how's the tractor going? Because he was so enthusiastic about it. Oh, that thing, they can come and take that away any day they want to. I said, why? What's wrong with it? It was down for 2 days because a sensor under the tractor seat had failed. And no, it took them a day to get someone out, day to fix it, usual stuff, usual thing. So they lose confidence in the technology. That's my worry. Yeah.
Thanks very much, Andrew. I think we've probably brought things to a conclusion for an autumn Wednesday night, and I'm just looking through. As I say, we've held on to the audience very well. Rupert, do you want to? I noticed you got your microphone on there. Do you want to close out things?
Well, yeah, I was just I switched the video on as well. Not that you particularly want to see me, but it was just various people walking behind me, so I thought I'd switch it off. But no. Thank you, Andrew, for if there's no more questions, I'm just checking. No one. No. Just I'd like to say thank you as chairman of the branch. Thank you very much for giving this talk this evening. Our first on Zoom, our first proper meeting, I would say. I think it's great to see the interest from other parts of the country. I noticed Andy is on the call from, I assume you're way up north, are you, or are you in Poland?
I'm in Poland.
Oh yeah, all right. Well, even further away then. Yeah. So I think this Zoom system is great, that we can reach not only around the branch, the Western branch itself, but we can invite so many people in from other branches. I'm sure next year when we when we get back round to having proper meetings at places like Lackham and Cirencester, Tom, when we're allowed to, we can set up a webcam and a laptop and broadcast this, any of our meetings to those that can't attend or people from out of the area. So I think this has worked very well, and I think I'm sure we'll carry on with this this setup. You know, it won't just be for this period of COVID. It probably be the future of our meetings. But going back to your presentation, Andrew, all very interesting, very different to my background. So I'm sorry I don't have any relevant or relevant questions for you. But no, I'd like to. I suppose this will be a first, do a sort of a virtual show of appreciation and ask everybody to give Andrew a round of applause.
Great.
As we would normally do in a meeting. So yeah, thank you very much, Andrew.
Thank you, and I look forward to coming to some Western Branch meetings once this lockdown.
You're certainly very
far away, so
yes, yeah,
visits.
You're very welcome. Yeah,
we a great deal with the Western Branch.
Yes, yeah, we have to work that out, Mike, don't we? The rest of our program for the next few months. So
Okay.
To be confirmed, but there is a shopping list of activities.
Okay.
Virtual and non-virtual. Yeah. So.
Right. Good night, gentlemen. Thank you for your attention.
Yeah.
Yeah.
Good
Thank
night.
you very much.
Bye.
Thank you. Okay.
Thank you.
All right. Bye then.
Good.
Bye.